To another video today. This is extreme weather. My friends Andrew and Sheriff are here to explain with me the winter weather, the severe weather, and I will be explaining the winds that will impact California from this upcoming major system that will impact basically every part of the United States west of, I'd say, Pennsylvania. This is a major storm. A lot of snow, a lot of severe weather, and a lot of wind will be upcoming, and it is very important to talk about. So, firstly, let's jump into the maps that are up from the National Weather Service, and basically, what we can see here is a lot of warnings, basically, that are up. We can see around the basically the entire plains up into the Midwest, there is a winter weather advisory. And
you mean winter storm watch?
Winter storm watch, not a winter weather advisory. I'm sure there is winter weather advisories, but winter storm watches are also in effect. We can see that down where there is currently a marginal risk of severe weather by the Gulf Coast, there is a flood watch. That would translate to a flash flood watch, obviously. And we can see up in California, there is wind advisories and there is freeze watches. So let's jump right into it. You can see all the warnings with the sidebars to say what is what. If you'd like to pause the video and check that all out, go right ahead. That is what is currently going around the United States. So the first thing we're going to be talking about is the offshore winds for California, northern and southern. This is a major event. Just like last week's event, I'd say it's not going to be quite as strong as last week's event. However, it does look like it could be quite the strong and widespread event for most parts of California. So we can see that the National Weather Service in Los Angeles has issued a daily area forecast discussion in which they said that the Santa Ana wind pattern Wednesday through Thursday is here, and that they do think advisory level Santa Ana winds will be likely Wednesday and Thursday across the Ventura and LA County areas. Now, if we jump back over here, they actually have not issued any advisories for the Los Angeles area. However, the chances that they do issue a wind advisory are very, very high at this time, if not even a high wind warning for the more wind-prone areas in Southern California. But I'd say we're pretty locked in for a wind advisory at this time, and I'm going to go more into detail on what each wind aspect is for each area in California. I'd just like to quickly say that if you're here for, say, the severe weather part of the video or the winter weather part of the video, you can skip right ahead to those parts. Because I will be talking about this for a solid 5-ish minutes, and then we'll jump into the more impactful parts of the video. So, yeah, that's the NWSLA AFD. Let's go jump into some maps. Alright, so welcome back. Now let's look at our actual surface winds and wind gusts. We're going to first go with sustained winds, and take this with a grain of salt because models typically don't do that well surrounding wind, sustained wind, with these kind of high-resolution models. They do much better with wind gusts. However, with sustained winds, they usually underdo or overdo them. So take the sustained with a grain of salt. What's going to be more important is the wind gusts. So let's go ahead and start looking at this. We can see Tuesday, actually, let's go up to Northern California where it's going to be intense first. So we can see this is our sustained winds, already a solid 19 to 20 miles per hour in a very widespread area of the Sacramento Valley out in this region. I don't think I have to highlight it for you. You can see those greens and yellows color. But if we keep going forward, the winds are going to intensify quite a bit, and they're going to become very widespread at one point, and then they'll start lowering. So I would say sustained winds, probably around your 20 to 25 mile per hour region in some areas. However, the Sierra Nevadas, as is typical, I mean, this is the Sierra Nevadas after all. I mean, we could be looking at sustained winds upwards of 40 miles per hour if the NAM 3-kilometer model does come true. However, again, this is the Sierra Nevadas. It's always stronger up there. It's higher elevation. You're going to get more flow. Now, this is the wind gusts. Let's go back and look. So around Sacramento, around 5 p.m. Tuesday local time, so Pacific, You can see those wind gusts really approaching that 35 mile per hour range. If you don't know what I'm talking about, down here is a key for you. That 35, 40 mile per hour range, but if we keep going forward, they're going to approach that 50 mile per hour range up here north of Chico, north of Grass Valley, this general region up here. And then really once we start going into night, they should start calming down, but once again, the Sierra Nevadas just always prevail, and look at the Sierra Nevadas really just starting to pick up, with the NAM 3 kilometer showing gusts upwards of 60, 70 miles per hour in the higher elevations of the Sierra Nevadas, and I would definitely not rule that out. Seems pretty realistic from a meteorological standpoint. And now let's go back down to Southern California, where we can show you that the winds are going to increase as Northern California decreases. And we'll start off with winds that are sustained. So around 5 p.m. or 1 a.m. Wednesday, winds start to increase around 18, 19 miles per hour north of Burbank. Now we're starting to really get some stronger winds, widespread in the 27, 31 mile per hour region off the coast, 35 miles per hour sustained. The NAM 3 kilometer showing winds sustained around 45 miles per hour out in the desert of Riverside and San Bernardino counties. And winds really, really intensify upwards of 35 miles per hour in the LA, San Bernardino mountain lines up here, where the winds do typically get strong during Santa Ana wind events. Now let's go look at gusts. And we can see that gusts really, really are intensifying, especially as we go into the night and the day of Wednesday. Widespread 35 to 40 mile per hour gusts with gusts up in the LA San Bernardino mountains. The NAM 3 kilometers showing around 65 to 70 miles per hour. And again, in those higher elevations, it is totally normal to get like stronger winds. And again, this event doesn't look like, from a standpoint, that bad. I mean, it's nothing like we saw a week ago, but it definitely looks like it could be one of the stronger wind events, at least for the season, considering that this season was one of the lower end in terms of intensity. And one more thing I do want to mention, although it will be dry and windy in Southern California, fire weather is not going to be that big of a concern with this event. And I know that's hard to hear, because like fire weather is usually a huge concern with these kind of events that are widespread and dry. But because this is going to be bringing in colder air, the temperatures won't be that high, and along with that, the recent rains have really soaked fuels, and to get fast-moving wildfires and intensely burning wildfires, you need more of the dry fuels. And I would say with this event, like, of course you could get a fire to start and it could spread faster than normal. Like, that's totally normal, and that's probably expected if you were to get a fire to start where those stronger winds will be. However, in terms of like widespread fire weather that is extreme that we would see with this kind of event, say in October, that kind of thing is not being expected with this event. So now with that said, let's move on over to the winter aspect of this.
Andrew here filling in for extreme weather. This is going to be the winter weather and severe weather side of things. So let's get started. Here's day one map. We have some thunderstorms across Texas and Louisiana, bringing some flash flooding and isolated severe weather chances there. As we move along, here's day two. Your winter storm starts really heating up, and then there's day three. Let's go to the front map. You can pause this whenever you want to. I'll just quickly go over these. This is your change to snow at 0Z, 12Z heavy snow, freezing rain. Again, dynamic system with heavy snow, freezing rain. Severe weather is possible in Louisiana, Mississippi at this point, and then snow is exiting the country. Here is the probability for a foot of snow. Anywhere in the greens and blues, it's possible that you see a foot of snow. Now, the lighter the color, with the green and the yellow and brown, that's where it becomes more unlikely. Anywhere in the dark blues to light reds, it's getting likely to see a foot of snow. So some cities I would include, areas like, I believe this is going to be Kalamazoo, Indiana there, areas near Kankakee, Illinois, Bloomington, Normal, Detroit, near Toledo, Fort Wayne, so areas like that. Now here's the winter weather hazard map. There are extreme hazards across northeast Illinois and then isolated pockets in Missouri that there's extreme hazards. So places like central Illinois here, it looks like this is Springfield, Peoria, Bloomington, Normal, and then a large patch in here. This is where 18 inches is possible, so that's why it's like that. And then Fort Wayne. and then Columbia, Missouri, extreme impacts are possible. A large area of major to moderate impacts are possible as well. Now, here is again another interactive map with this. Here's like overall. If you can pause if you want to. Now, here's the National Weather Service blend of models. This is going to be your totals. I will zoom out for the region of the Midwest here. Anywhere in Kansas City, anywhere from 6 to 8 inches. Areas like central Illinois, a large swath of a foot is possible. And anywhere in these reds, a foot. That's a foot of snow. And anywhere in those purples, it's over 6 inches. And then the blue colors is over an inch. Here's going to be the full United States here. I will also get it out to the time frame where it exits the United States. So there's Maine with almost a foot in some areas, New York and Vermont with pockets of a foot, and yeah. The ice, this is going to be another significant focal point. Over a quarter inch is possible with those darker purple colors in here and here. And the ice is going to be something that's going to be overlooked with this storm, but that's going to be a very significant hazard, and you're going to really need to be prepared and not go on the roads whether you're having ice or snow. Now, something I did forget to look at is the probabilities of seeing 4 inches of snow for like all the days overall. So here's day 1. This is day 2, and you have anywhere in the greens is possible, blues is unlikely but still possible, and red is likely. With this map, the greens, it's possible, the blue, it's probable, and then the lighter blue, it's likely, and the red and the light red is it's expected. All right. Now let's go on to the ensemble part. Here's what the NDFD shows. I'm not sure if this is an ensemble or not, but it's something that only I'm pretty sure only Weatherbell has a very significant amount of snow. We'll go into the Illinois and Indiana region. It has a large swath of over a foot there. If we go out to the North Central region again, oh, that's not the right region. Whoops. The Great Lakes region again, over a foot for anywhere in those pinks, over 10 inches. Here are the Euro ensembles. Anywhere in those pinks again, that means over 10 inches of snow is expected, with the blues being over 2. So again, this is looking like to be a very major winter storm for portions of the Midwest and into the Northeast, extreme northern Northeast. And I would say if you were, you need to prepare right now if you're in those areas getting hit with this, because you don't want to be stuck outside with this storm like this tomorrow night or into Wednesday. So get your supplies now. The GEFS ensemble, we'll go through the precip of it because you can actually do that with this model. It starts off as rain for places like Illinois, changes over to freezing rain briefly for a little bit, and then we get snow to start to fall, and that's when it changes to snow for the majority of the event, a very significant ice event from Texas all the way into Ohio, PA as well. Now the GFS, here are its totals of snow. It's a little bit further south. I do expect this to be on a path a little bit more like that. It'll be a little bit more north than what the GFS shows. It's a little bit more south than the Euro. We're just going to compare the two. Here are the Canadian ensembles. This is another very realistic solution, another area where it shows a foot of snow from Missouri all the way into the Northeast. This is another one that's a little bit further south, but it's not too far south. It's definitely a realistic path. We see anywhere in those darker pinks, those are over a foot of snow. Now, here is the RAP model. We have it zoomed in on the Midwest, but we can zoom it out to the continental United States here. This only goes out for part of the event. So, yeah, but here we go. We see the low pressure start to get forming around 22Z. We see some areas start to change over to snow and then really fully changing over to snow right before midnight. And then this is when heavy snow across Illinois just keeps going. We have a little bit of a break as we get late into Wednesday, but another round is incoming. Now, how much snow fell with this round? You had over a foot fell from Kansas all the way into Michigan. And then you also had some pretty significant ice amounts fall in Illinois, Missouri, Oklahoma, a little bit of Kansas there, and a little bit into Indiana as well. Here is what the NAM model shows. Snow really starting to get going. Then some freezing rain as well. More snow. This is when severe weather would be happening in Dixie Alley, and I will talk about that in a second here. Here are the snow mounts with the couture method again. A large swath of over a foot from Kansas all the way into New York. Here are the freezing rain amounts. We'll just cap it here. I'm going to use this method because it's a little bit more realistic here. The NAM is showing a wide swath. Anywhere in those darker purples, that's where over a quarter inch is possible or is forecasted by this model. This is not going to look like this. I don't think they're going to have this wide of a swath like this, but you're going to have isolated areas that do achieve over a half inch. Now, let's transition into the severe weather side of things, because there is going to be a chance for isolated to scattered severe weather with this, especially across Louisiana and Mississippi. Now, something I first want to mention before I even get into it is that models like the HRRR have a lot higher moisture than, say, the NAM 3 kilometer or regular NAM. So it's going to be interesting in the coming days to see what happens with this and to see if these models trend to more instability across the warm sector, because that would yield a higher severe weather threat. Now let's go to the NAM model. We'll stop it at 21Z and we'll go look at some stuff in depth here. You have your line of convection, broken line here from Tennessee all the way into Louisiana. Anywhere in these dark blue colors in Alabama, Florida, Louisiana, and Mississippi, those are your dew points that are going to be above 60 degrees. In here, these are dew points in the mid 60s, and in those the darker the colors go, the stronger the dew points. So those are going to be upper 60s. Now let's look at your surface-less cape crossovers, and you see here anywhere in those grays, that's going to be 100 to about 900 cape, and then we have in the blues 1,000 or higher. So this is where your highest instability is, right there. Now here are the crossovers with that. The crossovers are basically taking the low levels, the mid levels, and the upper levels there. This crossover is very favorable for tornadic activity and more supercell activity. This one's pretty favorable. This one's more of a linear one. This is more linear. This is more linear. This is more linear. This is decent. This is decent. Decent for tornadic or for supercell activity as well. Now, what we're most likely looking at is a line of storms with embedded supercells in it and maybe a couple out in front. There's your mixed layer cape. Now, how about we take a box sounding and I will analyze it. So here's the box sounding. We have a pretty enlarged photograph here with around 250 0 to 1 kilometer SRH, which is more than enough to get tornadoes and rotating storms. We have mixed layer cape of 1,000 joules per kilogram as well in this area, with 3 cape of 90, which is very solid. 6 kilometer shear of 40 knots isn't terrible, along with effective shear of 35 knots. That'll get the job done. It's a little bit low, but it'll get the job done. Low level jet of 30 knots. Now, the thing that's lacking with this is your lapse rates. They're 5.9 at the surface and 6.2 in the mid levels. That will make the destabilization lack a little bit more, but we have a decent enough K profile that it could make up for that. That's basically going to say that hail is pretty much out of the equation unless it's super isolated. And I do not know what's happening with my marker right now. That is funny, but here's the 0 to 1 kilometer SRH overall. We see a pretty large area of it. Here is a sounding, plot sounding here. We'll take one in northeast Louisiana along the Mississippi border. Not a great photograph there, but solid instability. Here is one in central Louisiana, or south central Louisiana there. Solid photograph, but not great instability, probably because it's close to the coast. Let's take one a little bit further north here. Okay, this is where we have more solid instability, especially with the mid-level lapse rates being 6.4. That's not bad. And a decently large photograph as well. Now, the winds are not very crosswise. We see the 1 to 6 kilometer barbs are not changing much, so this would likely be this is a linear sounding and a crosswise sounding, as we call it in the weather community. This is a pretty common sounding for QLCS type tornadoes. Looking at your low level jet, you have values in the 40 to 55 plus knot range, 500 millibar shear of 40 knots to 60 knots as well. And here's your surface winds. These are going to be bringing up some pretty warm moisture. Not the greatest surface winds ever. but definitely winds of 5 to 10 to maybe 15 knots in some areas at the surface as well. And that's it with the NAM model. We're going to go to the other models like the GFS now. The GFS definitely does have a tendency of underdoing the moisture. And here it is again. We'll go to 18Z because that's probably when it's going to have the highest moisture. Here's a sounding in kind of north central Louisiana there. Moisture's not bad, but I do think it's lacking some shear actually, which is a little bit surprising. Surface temperature is a bit stronger on the GFS, and that would yield higher lower level lapse rates as well, and probably a bit more surface destabilization as well. Again, the GFS is pretty similar kinematics to the NAM, except it has a little bit less low-level jet energy and a little bit less 500 millibart energy. Now, we're going to go to the Euro. It's running right now for this event. This is the 18Z run. It shows 70 dew points in eastern Louisiana there. And if we look at the soundings, they are relatively solid. Now, that will do it.
To leave, I will be doing this Q&A commonly asked questions section on my own, in which I will basically just answer any commonly asked questions that I think people would probably have surrounding this upcoming major storm. And the first question, like, I would think people would have is, how much snow are we looking at for the Midwest? And I would love Andrew to be here to answer this one, but I think I can answer this one on my own. I think we're looking upwards of 2 feet in some specific areas, with localized areas in that range, and widespread around probably less than a foot to around a foot range. And again, you can go back to Andrew's section and see all of those maps that he showed, and those will answer that question for you. The second question is surrounding the severe weather that I think people would have. Like, how big is this severe weather event going to be? How much tornadic activity? Is this a big tornado outbreak? Is this a severe weather outbreak? What is the main threats? And I do know severe weather myself more than I do winter weather, so I can answer this one. And basically, as Andrew said, the photographs and really the fact that you're going to have like a crashing cold front would favor more of a linear setup with this event, and it's more likely that damaging winds will be the main threat of the severe weather event. And you can't rule out, with the kind of kinematic profiles that you have, the low-level jet, the kind of shear, SRH, those are kinematic profiles. You can't rule out tornadic activity within that embedded line. However, I would say that, like, if we're looking at a tornado outbreak, this isn't the kind of event, and I definitely wouldn't say severe weather outbreak at this time. The severe weather aspect will definitely not be the main threat of this entire sequence. It's more the winter weather, or sorry, not more, it's definitely the winter weather aspect of this. However, severe weather can be impactful, and it's important to touch upon it. And then the final question that I think people would have is surrounding the wind event for California and the western regions from this trough that's going to be digging through. And the question I think people would have is, how strong will the winds be? Will there be fire weather? Things like that. The winds, it's still far out, and these change. It's very fluid. That offshore wind events are very fluid. They change very quickly, and I think that you're looking probably at a solid, moderate type wind event, Diablo and Santa Ana, and it's possible that that could be more strong than moderate, but right now it's too far out to really say that. We only have one high resolution model that's even in range to show this event, so I don't want to overstep here and say something that's not true, because we do go by giving accurate information, unlike a lot of other weather YouTubers, and that's why we urge you to keep following this channel. Alright, that's it for the video, and thank you for watching.